Good evening, student. Today we talk about step mechanism, step and mechanism of action potential. So let's start. The action potential is a crucial signal that transmits information along a nerve cells, and it's fundamental to the functioning of the nervous system. The process involves a rapid change in a membrane and potential of a neuron, resulting in transmission of signal from one part of the neuron to another. First stage is resting membrane potential. At rest neuron membrane, a negative change inside the cell relative to the outside. This resting membrane potential is typically around minus 70 millivolt, and it primarily due to the unequal distribution of ion across the cell membrane. Sodium Na plus and chloride ion are more concentrated outside, while potassium ion more concentrated inside. And second is depolarization. As you see in image, the action potential begin with depolarize, a change in membrane potential towards zero. These occur when a stimulus such a neurotransmitter binding to the receptor on a neuron membrane open ion channel. In most neurons, this involves sodium channel opening allowing sodium ions to reuse into the cell. As a result, membrane potential become less negative. And third stage is threshold. Threshold for an action potential occur, the depolarization must reach a certain threshold level, typically around minus 55 millivolt. It the stimulus is strong enough to bring the membrane potential or beyond this threshold, the neuron will generate an action potential. Four, four stages rising phase. Once the threshold is reached, voltage sodium channel open more widely, allowing a rapid influx of sodium ion into the cell. This causes a positive feedback loop as the increasing positive charge inside the cell further opens sodium channel, leading to a rapid and substantial rise membrane potential. And fifth stage is repolarization. That's mean K plus ion out. Let's discuss to repolarization. As a membrane potential reaches its peak around minus 30 millivolts, sodium channel begin to close and voltage gated potassium channel open. Potassium ion exit the cell, contributing the repolarization, restoring the negative charge inside the neuron. This marks the falling phase of action potential. As you know, this marks the falling phase of action potential. And our sixth stage is hyperpolarization. Let's discuss to hyperpolarization. In some neuron, the movement of potassium ion is sufficient to cause a brief hyperpolarization where a membrane potential become more negative than a resting state. The hyperpolarization is a temporary is due to slight delay in a closing of a potassium channel. And seventh stage is sodium potassium pump. What is seven stage sodium potassium pump? Let discuss to sodium potassium pump. Following hyperpolarization, the sodium potassium pump actually transports sodium ion out the cell and potassium ion back in, restoring the original distribution of ion. The process consumes energy in the form of ATP, but is crucial for resting the neuron to the resting stage. And our eight stage refractory period. After an action potential, a brief refractory period occurs during which the neuron is less responsive to another stimulus. This ensures that the action potential travel in one direction along the neuron and allow time for the restoration of a ion concentration. So let's summarize to our step of our action potential. So in summary, the action potential is precisely a orchestrated sequence of event involving depolarization, threshold rising and falling, phase repolarization, hyperpolarization, and the activity of ion channel and pumps. The process enable neuron to rapidly transmit signal over long distance, facilitating communication within the nervous system. The interesting of the action potential highlighted the remarkable electrochemical dynamic that underlie the functioning of the nervous system. So this is all the step of action potential. I hope you guys like this video. So like, share, subscribe and comment. If you want more video, then please mention in comment box. Thank you guys.